Hello everyone, welcome to Augmented. In this session, we will be learning about Python NumPy searching arrays. By the end of the session, you should be able to understand searching arrays, search even values, and search odd values. I'm excited to get started and I hope the same from you. Let's get started with searching arrays. So you can search an array for certain value and return the indexes that get a match. To search an array, you can use the where method. There we go. To the where we can actually specify the value that we are looking for. That should be inside an array. Now let's see how to search for even values. So we can find the indexes where the values are even by writing the condition. That is, each of the array elements should be we'll be checking for the divisibility by 2 by writing array variable mod2 equals 0 and passing to our where method. So that should search for all the even values from our array. Also, we can search for the odd values. So here we can find the indexes where the values are odd. Again, to the where function or method, we can pass array mod2 equals 1. That should return the indexes where we have the odd values. Now let's hop to Python and check out the example of array search. I'll see you there. Now here I'm in my Python, so I'm going to right click on my NumPy folder, go and create a new Python file, and let's name this as array search. Hit enter, and let's say searching is looking for a certain value and return the indexes that get a match. So here to search an array, we can make use of where method of NumPy. So let's go and see an example of this. So first of all, I'm going to import NumPy as NP using the import statement, import NumPy as NP. Let's create an array. Array equals NP dot array. I'm going to create an array having elements 1, 2, 3, 4, 5, 4, 5, 6, 6. And here I'm going to say x equals NP dot where array equals 6. So I want to find the indexes where my elements are 6, array elements are 6. So that is why here I have repeated the elements in my array, and I'm gonna print this x. Let's run and check the output of this, and there we go. You see I get array as 7 and 8, b type in 64. So if you look for the indexes here, this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So I have 6 at index position 7 and 8. That is why it is returning the index position of arrays where my element 6 is sitting. Or I can just go and add 6 here. So this should say me 0, 7 and 8 because indexing starts from 0. Sorry, 0, 8 and 9 because our elements are going to move by 1. So this becomes 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 obviously. Alright, because I've added an extra element at the index position 0. So this is how you can search for array elements using the where method that will return the index positions of the specified array element. What if I go and check for element which is not present in my array by writing np dot where array equals let's say 9. So I do not have 9, and then I would just go and print x and check if this works. You see, this gives me an empty list or empty array because in my array we do not have the element 9. That is why it's just returning empty array. Remember, this doesn't give us an error but returns an empty array. Now let's find the array indexes where the elements are even. or where values are even. So I'm gonna create a new array here. Let's say array 1 equals np dot array, and then I'm gonna say 1 2 14 3 3 5 9 12 28 32, and then I'm gonna say x, sorry, array equals np dot where, and here I'm gonna say array 1 mod 2 equals 0. And then if I go and print my array, let's run and check if this returns the index position where my values are divisible by 2. So you see 2 is divisible by 2, that is why this is index position 1. Next comes 14, so this is at 2. Next comes 12, this is at 5. Next comes 28, this is at 6. And next comes 32, this is at index position 7. Alright, so this is how you can find the indexes where the elements are divisible by 2. Similarly, I can also go and check for the elements that are divisible by, not divisible by 2, that is odd numbers. So if you notice, it's actually returning the index positions of elements that are even numbers here. This will return the index position, so you can see odd and even numbers both here, but this is actually returning the index position of even numbers in my array. So similarly, if I create another array, let's say np dot array, and here if I say 2 3 4 1 11 16 14 22 19, and then array equals np dot where, I'll check for two conditions here. One is array 1 mod 2 is not equal to 0. Okay, and then I'm gonna print array, and let's run and check if this gives me index position of numbers that are odd. So odd number we have at 1, that's true. We have at 0 1 2 3 3 4, yes, and then 5 6 7 8. Okay, let me also check with array equals np dot where array mod 2 equals 1. Instead of telling not array mod 1 not equal to mod 2 not equal to 0, I'm saying array mod 2 equals 1, and let's check. Let's print the array and hit enter, and there we go. You see this gives me output as 1 3 4 8. Now why is it giving me elements 1 3 4 8 here? Or one second, let me, oh, this is actually an error, because it should be array 1. That's what this was actually the output of previous I had written. This should actually give me the same output 1 3 4 8, because this array 1 mod 2 not equal to 0, we can alternatively write array 1 mod 2 equals 1. So both of them should give us the indexes of odd elements of our array. Now here we also have a method called search sorted. Let's see how it works. So search sorted method performs binary search in the array and returns the index where the specified value would be inserted to maintain the search order. And this search sorted method is actually assumed to be used on sorted arrays. Let's go and see an example of this. Let's say array equals np dot array of 5, 6, 7, 8. And then here I say x equals np dot, as soon as I write search, you see I got search sorted. So I'm going to use the search sorted method, and let's say I'm going to search for 7. And then let me go and print x and hit enter. Let's see what output it gives. It is giving me the index position where 7 is occurring. So I have index 7 at index position 7. This is 0, 1 and 2. That is why it gives 2. What if I have 7 multiple times? And let's run and check. It still gives me 2 because it is giving me the first occurrence of 7. What if my 7 was present here at first? So that should be 0, 1, 2 and 3 this time. Let's run and check if the output changes to 3. Okay, so see what's actually happening. I have to rerun. This is 0, 1, 2, 3. So what's actually happening, if I go and write 8 at the end, and now if I run, this will give me the output as 2 again. What if I say something like 4, 5, 6, 7 and 8, and now you see it should change to 3. As I already mentioned, that search sorted is going to be working on sorted arrays. It means the order 4, 5, 6, 7. What if I write 8 here and then 7? It was not giving me the output, even though I had written my 7 at index position 3. So this always works on the sorted array, search sorted method. Now let's go and see how to search from the right side. So I'm gonna say search from right. So here by default the leftmost index is written. What if I have to search from the right side? So here I'm gonna create another array. Let's say a equals np dot array. Let's say the array elements are 6, 7, 8, 9, and x equals np dot. Again I'm gonna use search sorted, to which I'm gonna pass array comma 7, and then third argument would be side equals right. Okay, and then here I say print x. Let's run and check the output. And there we go. You see, it says 2. So this is 0, 1 and 2. That is why I get the output as 2. Right? What if I have 10 here? So this should be 0, 1, 2 and 3. Now if I run, okay, again this is 2. Yep, because I actually have to insert element here. And now if I run, you see it gives me output as 3. Not from the right side, but from the left side I have to insert an element. Alright, so this is how search from right works. Now let's see how to search for multiple values. So here I'm gonna say search multiple values. So here we have to pass an array with specified values to a search sorted method. So here I'm gonna create an array. So array equals np dot array of, let's say the elements are 1, 3, 5, 7, and x equals np dot search sorted array comma, here I'm going to pass list of elements as array, or array holding multiple elements, let's say 2, 4, 6, and then I'm going to print x. Let's go and see what output it gives. So if I run, there we go. You see it gives me output as, so this is actually returning the index positions 1, 2, 3 where this 2, 4, 6 elements could be inserted. So 2 could be inserted at index position 1, 4 could be inserted at index position 2, and 6 could be inserted at index position 3. In order to maintain the array order, because search sorted works on a sorted array. Also, if I go and add 8 and 10, so that should save 4 and 4. All right. Let's say only, because I have not used 9 here, right? So if I go and write 9, and now if I go and write 10, This should give me the proper output 1, 2, 3, 4, and 5. Now let's see one more example of a search sorted. I'm gonna create an array. Let's say array equals np dot array of 1, 2, 2, 3, 3, 3, 4, and 5. So you could see this array is sorted. So I'm gonna write a print statement that says array equals floor bracket. Because I'm using a placeholder, I need to use format method, and to which I'll be passing my array. Now let's find the leftmost index and rightmost index here. So here I say print something like leftmost index equals floor bracket dot format, to which I'll be passing this np dot search sorted method, and to which I'll be passing my array, and then 3 comma side equals left. Similarly, I'm going to do the same for right. So here I say print rightmost index equals dot format np dot search sorted array comma 3 comma side equals right. Let's go and check the output of this. So I'm gonna run, and it says module NumPy has no attribute search sorted. Oops, it should be this ways. And let's run, and there we go. You see the output here is leftmost index equals 3 and rightmost index is 6. Now in order to search NumPy array for specific elements, we have seen methods like where and methods like search sorted. We also have methods like argmax, argmin, then nan, argmax, and argmin. Now let's go and see how we can search for a specified element in the NumPy array using argmax. This should easily display the index of the largest element or the maximum element inside the array. Let's say this is argmax. Let me create an array here. Let me create an array equals np dot array. Let's create a two-dimensional array here. Let's say 12, 100, 99, 250, comma 300, 22, 56, comma 88, comma -1, and here I say 25. So in this array, I want to find the index position of maximum element. So what I can do is here I can say x equals np dot argmax. So you see I have this argmax to which I'm gonna pass at, and then I can print my x, or I can first print my array, and then I can print something like max elements index colon comma x. Let's run and check, and there we go. It says max elements index is 5. Alright, so if you see, because the maximum element is 300, so this is 0, 1, 2, 3, 4, 5. If I say 560 here, so this was 5, this should be 6, 7. Let's run and check if this gives me 7. There we go. You see, this is how you can find the maximum element. Now let's see how we can create an array with missing values in order to demonstrate the use of nan argmax function or method. So here I'm simply gonna create an array. Let's say array equals np dot array, and then write some out values here. Let's say I'm gonna say 12 and 100 99 comma np dot nan, and then I can say this is -1 0, and then here again I'm gonna say x equals np dot nan argmax, to which I'm gonna pass my array. This is a one-dimensional array that I've created. I'm simply gonna print my array as well as the max elements index here. So here I'm gonna say max elements index colon comma x. So 0 1 2 3 4 5, let's say, should give me output as 1. Let's run and check, and there we go. So this is not going to make any difference if we have any null values or missing values in our array. That is denoted by np.nan. Now let me check for argmin. So here I'll create an array. Let's say np.array of elements like -10 0 -1 -100, and then x equals np dot argmin, to which I'll be passing my array. Let me first print my array, and then let's say print min elements, minimum elements index colon comma x, and let's see if this gives me output as -100s, right? So if you see, this is 0 1 2 and 3. So my minimum element here is -100 or -100, and it is returning the index position of it. Also we can check with nan argmin. It should be nan argmin. I missed an n here. Okay. So yeah, again we can go and create an array with missing value. Let's say np dot array to the same array above. I'm gonna say np dot nan comma -10 0 1 -2. That's x equals np dot nan argmin, this one, and to which I'm going to pass my array, and then let's print array. Or also let me print minimum elements index colon comma x, and let's run and check, and there we go. It says minimum elements index is 1, that is -10. If I say -200 and run, this should give me index position of -200, that is 4. This is 0 1 2 3 and 4. All right, so this was about how we search elements in array using the where method, the search sorted method, where the array is supposed to be sorted and it should maintain the order of the array, then argmax, argmin, nan argmax, and nan argmin. So this was all about array searching. So that's all for this session. Hope you enjoyed this session. We'll see you in the next.